So I don't know if you've heard, but researchers in Japan have found a significant link between certain fatty acids in umbilical cord blood and the symptoms of autism spectrum disorder. So what fatty acids are we talking about, right? Because this seems like a big deal. It's this guy. This is the guy that I did my entire dissertation on. This guy and his cousins, right? And this is such a super niche topic that I am so excited to explain it to you guys because I never thought I would use this again. So I'm going to show you the metabolism and then I'm going to tell you a couple things that I think may be going on to cause this. So arachidonic acid is an omega-6 fatty acid and it can do a bunch of different things. It can go through the COX enzymes, COX-1 and COX-2 to become prostaglandins and thromboxanes, and those cause a lot of bad things. In excess, it causes inflammation, pain, fever, cytokine response, stuff like that. It can also, arachidonic acid can also be modified by the LOX enzyme to produce leukotrienes, which again cause a bunch of inflammation. This is actually what happens in asthma. You get a lot of leukotrienes. Or my entire dissertation, it can go through cytochrome P450 epoxygenases, get epoxygenated, and it make these really cool guys. They're EPETREs. Most people just call them EATs, like EETS. So if you Google this, just Google EETS and not the long name for them. Now these guys are amazing. They're fantastic. They are very anti-inflammatory. They dilate blood vessels. These things, increasing the level of these EATs has been investigated and is being investigated for a whole broad spectrum of diseases. Anything from Parkinson's disease to type 2 diabetes to obesity, Alzheimer's disease, dementia, chronic kidney disease. They're fantastic. Problem is, they only live for seconds, because this enzyme called soluble epoxide hydrolase breaks them down so freaking fast into the things that they found at really high levels in the umbilical cord. They're called DHETs. Just DHETS is the short name, not this one. These guys don't work. They don't do anything. They're very inactive. So when you have a really high level of these inactive DHETs, you have a lower amount of these active, very awesome EATs. And when we do studies on this system, we typically look at the ratio between DHETs and EATs, because we want to see maybe there are a bunch of EATs and that's why there's a bunch of DHETs. It looks like in this case, there were not. There were just a lot of these and not a lot of these. So what's going on in these children that are predisposed to autism is that there's more of the soluble epoxide hydrolase enzyme hanging around. So that means that it's going to convert more of the really happy EATs into the really not good DHETs. And luckily for you guys, I did a whole section of my dissertation about things that can make you have more soluble epoxide hydrolase be hanging around. We call it inducing increased expression, but there's more of it. So those things include tobacco smoke and alcohol use, obesity, but I'm pretty sure that they controlled for that in the study, high fat diet, but it doesn't push it really high that far, so I couldn't see it being that big of a problem in this. High levels of homocysteine, which is one of my main candidates for what's going on. Now, homocysteine needs to be broken down by using the folate cycle and the methylation cycle, and that takes folate and B12 along with a bunch of other stuff. There's at least one study that I found very quickly that found an association between decreased folate levels and decreased B12 levels and increased homocysteine levels all independently and an increased risk of autism. So that's awesome. We can fix that. That's so easy to fix. We just need to make sure that we're getting pregnant mothers all of that. Well, getting them folate and B12 so they can decrease their homocysteine level. But anyway, back to the list of things that can increase the expression of SEH. Next up is hypoxia. So low blood oxygen levels. This can either be from COPD or sleep apnea. I don't feel like that would be a really strong candidate for what's going on in all of these cases, but if somebody knows better, please let me know. I don't know sleep apnea rates in pregnant women. I have 3 more, and only really one of them I think is a good candidate. Angiotensin 2 can also increase expression, and so can estrogen, but again, too, I don't see this being a big player in pregnant women. And the last one I'm kind of nervous to talk about because it's herbicides and I don't want people to come for me, but it's literally what I found. I think as scientists we get put in tricky situations sometimes because we have a duty to report what we're seeing. even if we don't want to. So I'm literally just gonna read off of my dissertation. So I wrote, in one study using a murine model, so a mouse model, maternal exposure, so exposure of pregnant mice to glyphosate was suggested to increase SCH activity in the brains of their offspring, specifically in the prefrontal cortex, hippocampus, and striatum. Moving on from glyphosate to 2,4-D, I say 2,4-D is another widely used herbicide that has been shown to increase the expression of Arabidopsis SCH, which is, it's not like obviously an animal. It's a plant, and I cover it very clearly in here. I just wanted to include as much information as I could in my dissertation. And then I go on to say paraquat is a non-selective herbicide that has recently been gaining popularity in the US. While there is no existing data on the direct effects of paraquat on SCH expression, existing studies have been performed that demonstrate a pharmaceutical SCH inhibitor, so a drug that inhibits SCH from breaking this down, right? Decreases paraquat-induced neurotoxicity in rodents. So they use paraquat exposure to induce certain models of disease in mice, because it causes a lot of like neurologically toxic effects. And while they haven't looked to see if paraquat actually increases SCH expression, so makes more of it, they have looked to see if you can decrease its activity by giving these animals an SCH inhibitor, will reduce its neurotoxicity, meaning that paraquat is on like side A and side C is neurotoxicity, and SCH is at least one of the things in the middle that mediate that response. And they found that it did. But I will mention that herbicides increasing SCH expression isn't constant among all herbicides. Both diuron and siduron, I think is how you say it, have been shown to decrease SCH activity in larval flathead minnows. So again, not like a mammal study at all. But we don't have any studies on like paraquat or the last two I mentioned in mammals. Again, it's probably the homocysteine correlation. These mothers are having increased levels of homocysteine, and that's what's causing SCH, this guy, to upregulate and cause this imbalance. And if I were in contact with the researchers, I would push back and ask if they had more of that cord sample and to test it for homocysteine, because that would be an awesome study to do, and it would be relatively easy. You could even test it for like folate and B12 levels to see if there is also a correlation between decreased folate, decreased B12 in the cord blood, and an increased level of homocysteine. And that would just like, it would link all this stuff together so well. And you could even like test it for herbicides and see if they, the herbicide concentrations or presence was associated with later development of autism. So it's just really exciting. I never thought I would be able to like talk about my dissertation topic again, because it is very niche. But yeah, I hope them all the best. They've definitely got a lot of follow-up studies to do, and if we can figure this out and, you know, just save, even though this is not like 100% of autism, if this is just like 20% of autism, think about the impacts that we can make if we just reduce autism levels by 20%.